Welcome to another episode. Today I'm joined by Zero Age, part of the protocol team at Uniswap Labs and the mind behind some of the most battle tested standards in the NFT space and across DeFi. Thank you so much for your time.
Thank you for having me. Pleasure to be here.
Awesome. Today we're going to talk about his most recent creation, the Compact, and understand its implications on the cross-chain ecosystem. I want to start with a bit of background. You joined Uniswap Labs last year from OpenSea, and in your announcement tweet itself, you said you'd be tackling cross-chain swaps at Uniswap and building UniswapX. So, what made you zero in on cross-chain swaps as a problem, and how has your experience been till now?
I would say the journey to really taking an interest in cross chain swaps started all the way back at OpenSea, where we were constantly adding new chains and just being a part of the ecosystem. There are constantly new chains coming online, and the writing on the wall was pretty clear that this wasn't a phenomenon that was going to slow down anytime soon, especially if we want to get to global scale. I think most people intuitively understand that one blockchain is not going to be sufficient to power the global economy one day. So it was really more a question of when and rather than if. And it was also something that, at least at the time, was a really poor user experience in many aspects, involving a lot of trust, delays, fees. It's come a long way already, and I'm really excited for where I see things going with cross chain interop and cross chain swaps in the next uh, 6 months to a year, maybe even faster.
So let's talk about some of the changes in that 1 year, right? Like you said, things were not that great even a year ago. There was a lot of trust elements in the design, and then today things are looking better. But even today, there are different designs in the ecosystem, right? Especially in relationship to intents. And UniswapX is also an intent-based product, and that's your core focus right now. So how are you sort of thinking about building UniswapX while also making sure that the trust assumptions are kept in check?
Yeah. So I am absolutely very bullish on intents as a general concept. Intents are just a more elegant way to abstract a lot of the details of how to get something done to just what I care about getting done. And especially when you have complex routing and shifting uh, preferences and all of these things, that it's better to work as a team and let people who live and breathe finding optimal routes go and find the routes for you. And that's all well and good, but the key thing that has been holding back an fully intentful cross chain experience, which is where intents really shine, by the way. You have to come up with a route through multiple blockchains that is often asynchronous and all of this. It starts to fall apart though when the intent is not backed by a credible commitment, right? If I if I express an intent, but my my backing to that intent is not really solid, then no one can go and fulfill that intent with an expectation that they will receive the input tokens that I'm offering or whatever that is. So that's what really motivated the development of the compact, which is a protocol for building out resource locks. And the hope with the compact is that we can set up a relatively generic and flexible piece of public infrastructure to solve for this specific issue and really allow intents to shine to their fullest potential in the context of a cross chain intent and swap.
So when you say the backing is solid, like I'm guessing you mean the escrow contracts, right? Like in the intent-based flow. So maybe for the listener, help us understand like what is the difference between an escrow-based contract for intents and the compact-based contract for intents with resource locks and better commitments.
You can envision a very simple intent would be something to the effect of I've got a contract. I give this contract approval to spend my USDC. And this contract has logic saying you can only take my USDC if you have sent me ETH, right? So now we have a swap, an intent for a swap. If someone sends me ETH, but between them sending me ETH and going and claiming the USDC, I'm able to revoke my USDC approvals. Maybe I front run their transaction and pull my approvals. Then, unless this contract has logic that will revert the transaction or send the counterparty back their ETH if the USDC doesn't come to them, then you have a problem, right? I've backed out and effectively canceled my swap by revoking my approvals, or I could just move my tokens. There's a number of things I can do to equivocate, is sort of the terminology. So, to sort of cap off the point on equivocation, if you have the ability to go back on an intent, that's not necessarily an unworkable problem as long as you have atomicity, as long as you're in a single blockchain context, because you can always make any payment conditional or any fulfillment of an intent conditional on the receipt of actually getting back the tokens that are being offered. But when you get into an environment where you have multiple different consensus rules and different chains, that goes entirely out the window, and you need some exogenous setup for enforcing that everyone is happy at the end of the flow.
By the way, like how real is this risk, like in a cross-chain context? Because of course it can happen theoretically, but how many cases are there where it has happened? So I read a few bug reports where there were some critical vulnerabilities, but nothing happened in production, right? Like everything was patched. So I've never seen it happen or ever heard of it happening. But I wanna hear from you, like how real is this risk of something like this happening in one of the intent-based protocols that are live today?
So I think the right way to frame this is to just play it through from the perspective of a potential filler. That's been one of the main things that I think a lot of intent protocols are missing is they approach their architecture or the design primarily through the lens of a user, an end
Mhm.
user, and how do we make for an expressive, legible, and efficient, safe system for users, but neglect the filler story because ultimately fillers are not running charities. They are only going to participate in a system if they can at least operate at cost, and they will they'll bundle in any additional risk into the ultimate prices that the user has to pay. Now, in terms of is this happening, I don't have concrete numbers on it, but what I can tell you is that many systems have there's been a natural headwind to adoption, particularly at higher price points, because of this understanding, no rational filler it might not be worth it to even try to rug a filler for a $10-20 trade. But if you're trying a $10 million trade, the incentives all of a sudden become very significant to, if there's a way to not have to pay that 10-20 million dollars and to get the 10 or $20 million of tokens that you're swapping into, all of a sudden, as a filler, you're going to think twice because that's a very you stand to lose a lot of capital if it goes against you. And another aspect to this is many systems, the the natural defense to a lot of if you have to introduce some degree of trust that the other entity's not going to the counterparty's not going to try and pull one over on you, it naturally leads to reputation based systems where you're forced to know more about the counterparty. Do they have a good track record? Have they tried to rug someone in the past? What's their credit rating? All of these things, they start to really degrade much of what makes crypto as a premise interesting and valuable. And that's not to say there's not a place for all of these systems, but it's a smell if all of a sudden we've just gone full circle to you have counterparty risk that is just endemic. The whole point here is to build trustless, really resilient systems that are more transparent and democratized and don't have some of the same shortcomings. So it's ideally you have a way that you don't need to know anything about the counterparty that you're trading with. You just have full confidence that if they say they want to do a swap and you can see on the chain that they have made a credible commitment backed by a cryptographic signature and a durable protocol, that if you go and fulfill their intent, you may have to wait for uh, uh, the terms to be sufficiently verified by an oracle or uh, a verifier network or something, but that you will eventually be able to claim the tokens that they're offering.
Makes sense. So the
Yeah,
solution is to basically have a credible commitment that these resources will be there for the fillers to actually, get repaid with once they're done filling the user's orders.
that is correct.
And the compact is the protocol that actually allows for other protocols and other intent systems to issue these reusable resource locks.
Yes, and you have hit on a key differentiator and one of the top design goals for the compact, which is that it is a reusable resource lock. And to go into a little more context on that decision and the rationale behind it, there's a real risk with any kind of escrow, resource lock, you name it, of building what can, in a failure case, become a, a really restrictive piece of technology. Because as soon as you have placed funds into a resource lock or escrow that's specific to a certain application or a specific use case, now that capital is locked up there and may be locked up there for a significant duration of time and won't be able to be used for other things. And depending on the type of resource lock or escrow, it might be difficult to even get your capital back out. Um, it's not dissimilar to um, staking or something to that effect, where you you really don't have access to that underlying capital in the same way, and could even make an argument that it is not really a non-custodial solution. if it's only usable for one specific thing and you've given up significant control in the process.
Like I have an analogy for reusable resource logs. It's like sending a rocket to space and then not being able to use it again. But with the compact, you can actually reuse it for other purposes, like reuse that resource for different purposes. So from like a functionality perspective, that's how I like to think about it.
Yeah, there's also just the practical argument. Many pretty interesting iterations of resource locking involve effectively spinning up a specific lock for a specific action. One of the most elegant expressions of this is utilizing create to, where effectively your intent is encoded in the init code of some contract. You derive the address to that contract, you send your tokens to that address, and then you can deploy the contract, hence revealing the intent, triggering fillers to come in and follow up on it. Or the fillers can even deploy to that address, deploy the contract themselves and trigger the intent. This is cool tech, right?
Mhm.
But the issue is it's not reusable.
Mhm.
And especially in the context of a swap, which in an asynchronous context, there are even more things that can go wrong. If I want to um, set my slippage tolerance to a really conservative value, or I'm trying to take advantage of a route that is changing very quickly, or it's a market that's moving very quickly, you can imagine that the failure rate can naturally go up. And if every time that you want to try a trade, you have to set up a new position inside of a one off lock and then wait for that to settle, wait for fillers to have and solvers to have sufficient confidence that the tokens will be there, and then go and deploy and claim them, you're often going to be behind the ball. The market will have moved already. And now you have to unwind that position. And that's another transaction to go and get your tokens out and repurpose it to do something new. So the idea behind the compact is that you deposit once into the compact, and especially once those tokens have settled and are considered confirmed by the underlying consensus engine of the EVM that the compact is on, then they can be used for anything and they're instantly available as long as you have a signature, this credible commitment. But then if it doesn't work, if the intent is no longer fulfillable, or there's no counterparty, no filler solver that's willing to take it, now I can just try again with slightly updated parameters, or I can decide to do something entirely different, or I can even, in certain contexts where the funds are not at risk of being double spent, there's not some mutually exclusive um, claim against them. I can actually leverage the same underlying capital in the resource lock for multiple things at once.
Mhm.
So there's a lot of benefits to having a shared piece of public infrastructure that you don't have to spread your capital around multiple different idiosyncratic protocols and contracts and one-off escrow solutions, and that you're not constantly having to take it out and put it back in and make all of these frankly unnecessary
Mm.
transactions and eat this extra latency and cost and and complexity.
Yeah, I mean, when you put it like that, it sounds exactly like that, right? Like it sounds unnecessary. So my intuitive question is, why isn't everyone else doing reusable resource logs, and why are they sort of locking users into like an account based model where they have to have multiple transactions for every sort of like asset they want to use, and then each resource lock is tied to like a single account that works on certain applications and not on like other wallets. So why is there so much fragmentation across the way resource locks are being applied across the ecosystem?
I think that for a long time, protocols have been, and to their credit, I think it's actually not the wrong approach. They've
Hmm.
been focused on solving the specific issues that their users are facing for their application, for their chain, for their use case. It's it's sort of a tragedy of the commons type failure mode, where there just hasn't been sufficient reason to really invest in something that handles everybody else's use case.
Hmm.
And it's even there's an argument that working on something that is going to help what are, at least on its face, your competitors as well, is a dubious proposition from a business standpoint. I feel very lucky to work with a forward thinking and visionary group of fellow builders, both at Uniswap Labs and elsewhere, including our collaborators like LI.FI and Rhinestone, and people that can see beyond the immediate um, and myopic, self-interested take, and realize that we're all stronger together, that this is a problem that we need to work out, that the fragmentation failure mode is a real failure mode, and that in the long run, it's better for everybody to solve this in a really good, standardized, future-proof way.
Mm. And probably just to close the loop on like this specific topic. So Compact is on chain, and every contract is deployed on chain. It's ownerless, whereas all the other approaches towards doing resource logs, like they have their own credible commitment machine, which can be off chain, and there's like questions around transparency, and you have to sort of trust the team behind the protocol to do the right thing, right? So maybe if you can explain like the on-chain versus off-chain difference between the two credible commitment machines, I think that would be super helpful for people to like have a mental framework of how to think about the compact versus the other credible commitment machines in the ecosystem.
Sure. So the first thing that I should mention is the compact can be entirely on chain. However, it breaks out a couple of different actors that can optionally be on chain, off chain, or a hybrid of the two. And there is, I think, uh, a compelling argument that in certain use cases, certain applications, you don't necessarily want to be fully gated by what's happening on the specific chain that the tokens are
Mm.
held, right? If you're doing everything on mainnet and the tokens are on mainnet, maybe you don't want to have to wait 12 seconds to be able to confirm a trade and are happy just waiting for the settlement. Um, so you can define various actors in the compact parlance. The key actors are the allocator, who protects against double spends, as well as the arbiter, who determines when to process a claim against a compact. And those can be off chain or hybrid entities, though. Strongly advise that projects that are building on the compact consider ways to support fully on chain options, particularly on the arbiter side.
Mhm.
Um, but the compact itself, the protocol, is indeed a fully permissionless on-chain protocol. And that has a number of benefits over, for instance, a, a lot of resource locks, leverage, some combination of MCP or other off-chain account-based abstractions. So what this is effectively doing is saying, I'm going to hand off a, some element of control over my actual private key to a third party who can prevent me from taking certain actions if it would result in a double spend or in a credible commitment I've made being equivocated. That's problematic for a number of reasons. The transparency is a difficult thing to really provide in terms of the benefits. Most answers or solutions to that inevitably involve trusted execution environments, TEEs,
Mhm.
or something like that, or multi-party computation. Um, it also just damages this idea that you should be able to bring your own wallet, decide your own fate. If you already have tokens, they need to be migrated to a new account that has arguably dubious security properties compared to what you already know is and have vetted that, okay, I've got my secure hardware wallet with backed up seed phrases and all that. You can't do that now if
Mhm.
you have to migrate to an account where you.
Is that a good sign for users? Like if they have to migrate to a new account, they're probably using something that's off chain, or like they have their own proprietary stuff going on there.
I'm bullish on the premise for, especially for vertically integrated applications where you are bringing on a user from square one and their whole user journey is mediated through your application, and where you want them to be able to quickly and seamlessly interact with many different blockchains, including non-EVM chains or off-chain applications. But it's fundamentally a different problem than the one that I personally am really interested in trying to solve, which is how do we cater to the broadest cohort of new and existing crypto users that want to bring their own self custody solution, or you can also support systems that are a little more vertically integrated. Um, but yeah, it, if if the end state for the vast majority of users is effectively not dissimilar from just using a centralized exchange, that to me doesn't excite me to be working on. Um, Whereas if it's something where you truly have a way to do this in a self-custodial way, that to me is really compelling.
And let's say a protocol is actually building on top of the compact, right? Like, how would a user be able to recognize that, like, the protocol is using compact?
If like a someone wants to integrate with the compact, how do they go about doing that?
No, so that's a question for app developers, right? Like, let's say an app developer actually integrates the compact. How can a user identify that, okay, this is the compact in action and not some other resource lock mechanism?
Yeah. So anytime that you are interacting with the compact, we have we've worked very hard to make sure that there's a canonical and easily recognizable address that lives at the same address across different chains. So you would see that, you would see a consistent and familiar EIP 712 interface when you go to create a new compact or deposit in the compact. It's an interesting question to the extent to which these details will be abstracted away from the end user. And so I think it's it's more in the ballpark for application developers to decide how much they want to surface from the low level versus totally abstract details away.
Mm.
Um, but it's going to be interesting to see the extent to which users they should absolutely have the ability to peek under the hood and determine for themselves that something is what they're expecting. One interesting aspect of utilizing the compact, because we wanted to make it as expressive and generic as possible while still providing all of the core guarantees and primitives for a safe resource lock. The top level fields that you'll see whenever you're creating a new compact are going to be consistent. But every application is going to has the flexibility to specify what is called the mandate of a compact, which is effectively just the conditions. And that is a totally configurable witness data payload where what you see when you sign is typed data. It's structured data, but it will differ and can be anything that the application needs. That then the arbiter, who's tasked with actually verifying that a claim can be processed and triggering the claim processing, they then can inspect that all of the data in that mandate and use that to make an informed decision on
Mhm.
whether or not to allow the input tokens, the tokens inside the resource lock, to be claimed. So there will be a good deal of variability in what you see and how you interact with it, depending on the specifics of what you're doing. If you want to just bridge like tokens between different chains, that's going to have a very different mandate than if you want to do a swap or if you want to go deposit tokens into a, a automated money market or whatever. There's lots of
Mhm.
different things that you could envision. And one last thing I will just bring up as a cool feature of using something like the compact that would be quite difficult to do in other contexts. You can create intents that spend tokens across multiple chains. So I could say, I have USDC and Tether and DAI, and they're all scattered across 10 different blockchains in different amounts. I'd like to just take all of this and use it to buy ETH. I can sign one message as long as these funds are available in the compact. I just sign one EIP 712 payload and can offer all of them up as soon as I get the ETH I'm asking for on my preferred
Why
chain.
would it be difficult to do it in other mechanisms? Like if they're account based, I would assume that it's easier because like they have access to the entire account, right?
Almost everything is going to be easier in a purely account based model.
Yeah.
That's the easiest way to do this is I have my couple different stable coins in there, all on a centralized exchange. Look,
Yeah.
I can just sell them all, but not your keys.
Yeah. Yeah. Makes sense.
And so an account based model is like kind of your keys, but
Mhm.
yeah. So it's really, I don't, it would be difficult to accomplish this in a manner that doesn't involve handing off underlying control to a third party.
Makes sense. And in the case of the compact as well, like because there are other actors like the allocator and the arbiter, which the application decide, right? Like who's going to be the allocator and who's going to be the arbiter. Like those are the other two elements of trust for the users eventually. And again, there is no way for the user to actually see who is the allocator and arbiter unless they go read the docs.
So when you are depositing tokens into the compact, the user they specify the allocator they'd like to use. They don't actually have to trust that allocator beyond ideally the allocator won't claim that they are would be double spending tokens when in fact they aren't. That could temporarily censor a user.
Mhm.
But users always have the capacity to perform a forced withdrawal. They still are in full custody of the 6909 token that represents their position in a resource lock. It's a fungible position for anyone that shares the same allocator and underlying token. And the the period to perform a forced withdrawal can vary depending. You also choose that when you make a deposit. And the default is 10 minutes, which is plenty of time for most cross chain swaps to settle. So there's not a good deal of trust required on that piece. And it is the user that is choosing their allocator. Oftentimes, that will be mediated by the application and potentially abstracted away from the end user.
Got it.
But the primary entity that needs to trust the allocator is actually the solvers and the fillers, because they're the ones who are counting on this allocator not to allow a double spend. They're the ones that are making sure that these commitments are in fact credible that the users are making with their compacts.
Yeah, I mean,
Granted, it's a little different if you're a filler or a solver. Ostensibly, you are not abstracted away from the experience. You are and should be manually scanning the payloads, running your own verifications
mhm,
and simulations and all of that. That is very much the expectation. And there are also, for fillers that are more risk averse, they may prefer that only to use allocators that are fully on chain, that they've reviewed all of the code and vetted it and have no trust assumptions at all. There is additional latency in those cases over the pure off-chain or the hybrid cases, but it's a free market. Now, on the arbiter side, that is more a decision that you make per compact. It's not related to the deposit. You just specify any number of resource locks to use in a specific compact. And then when you sign that compact, you choose an arbiter that is going to be the ultimate determinant of when that compact has been, when the mandate has been fulfilled for it. And in that case, an application does have a responsibility to be a good steward for that specific action. But I see that as no different than any application that's generating any payload and presenting it to a user to sign, right?
mhm,
A bad app can ask a user to sign a transaction that will result in all of their tokens being taken from them. And in fact, that is what we see with a lot of phishing sites and other malicious entities and actors. If they can just trick you to sign a bad payload, then you're in trouble, right? So there is a basic uh, expectation that as an ecosystem, we push for users to, and this is another reason why I think having a good self custody is a really valuable thing, because now we can push users to use safe wallets that are scanning these payloads and having a good consistent interface to ensure, and simulation capabilities to ensure that their intent, their compact is in fact going to result in what they think will happen and not just have their tokens go up in smoke.
mm,
Um, Allocators can also provide additional security checks if you decide to go with an allocator that can serve as a second line of defense and will be able to detect that a given swap is actually just you're getting phished or having your tokens stolen. But yeah, it's a problem that I would have hoped to see more progress at this stage, but regrettably, it still happens to a good number of even uh, old timers in the ecosystem where they don't, and it's not really a fair analysis to say, well, you should be more carefully reading what you're signing.
It just happens, right?
It happens, and everyone shares some of the responsibility. Um, we should all be working to do better to ensure that people aren't getting scammed. Um, I'm very proud of the work that Uniswap Labs has done on that front to educate people as well as to provide proactive protection and working with other groups in the ecosystem to help protect users. Um, and I'm also very hopeful. Like I'm a real advocate for legible transaction signing and uh, utilizing EIP 712 and ensuring that every payload that you sign can be parsed, can be read.
Mhm.
The no opaque 32 byte hashes that you have no clue what you're signing for. Um, and then that also gives the broader ecosystem more opportunities to perform analysis of these payloads and automated scanning and threat detection and things like that.
Yeah. I mean,
So this is a great step in that direction too.
that's definitely something like as an industry we have to move towards, because at the moment, uh overall it just feels like going through a process, like you're just clicking and getting done with the transaction, but you don't understand what you're signing most of the times. So like if we actually have standards and like things that we can read and understand what we're signing, like that'll be a huge step forward for like UX in the ecosystem.
Absolutely.
And I also want to talk about like so the compact and resource locks are as much about the users and user experience as they are about improving things for the solvers, right? So what has been the reception and the feedback from the solvers or like the fillers front?
Most fillers that I've discussed with, and there have been a number of conversations going back a year and a half and longer to get to this stage. I think many fillers are surprisingly the the trust assumptions are a little different for fillers than they are for swappers.
Hmm.
And fillers tend and solvers tend to be pretty pragmatic about their approach, where they're willing to take on a little more risk as long as they can amortize it. They're they're really um, happy about not needing to do a bunch of custom integrations, right? However, you can make it as easy as possible to operate a filler and support different intents and frameworks and protocols. That's all a step in the right direction. Um, Another thing is that fillers, I think the number one issue that most fillers face as we lead into more cross chain filling and solving is inventory management. If I am operating a filler on a specific blockchain, I can maintain just enough inventory to be able to submit transactions and take out flash loans. And then as long as I identify a profitable opportunity, I can submit the transaction, pay the gas, take out the flash loan, swap just in time into whatever I need, go, perform the intent, receive the tokens back, unroll it, repay the flash loan, and walk away with profit. Sounds complicated, but it means that I can land one atomic transaction and not have to maintain a huge balance on
Hmm.
hand. Cross chain, you can't do that.
Yeah.
Not only do you need to source capital on the destination chain and provide it, but there's then often going to be some price risk between if I'm accepting a token back on the origin chain and I have to wait for it. Now, what happens if the price craters of that token? So I've got to build that in. I've got to handle rebalancing. So if more people are trading into a specific chain. Now I have to go and rebalance back to keep my inventory spread around in the right proportions across different chains. You can see, and the indexing, right? Indexing one chain in a performant manner is already a challenging task. Now, scale that out to N chains, which may have much faster blocks and a lot more transaction volume if you're dealing with highly trafficked L2s and whatnot. It it's a different tier of solver. So I think we're really focused on simplifying this process to the greatest extent possible, working with great groups like the Open Intent Framework and others who are really focused on democratizing access as to operate as a filler, make it easy to handle inventory management, just in time fulfillment, and rebalancing, and these really sticky issues around indexing and whatnot. So, yeah, that's hopefully that answers your question a little bit.
Yeah, I mean, it does. And it's all about like making life easier for solvers, right? At the end of the day, because intents will not exist if the fillers cannot actually do their job, right? So there are certain optimizations where you can actually make life easier and just make rebalancing easier, or like allowing them to have smaller inventories to do bigger trades, like be more capital efficient. So I think these are all moves towards that direction.
Yeah, it's interesting you say that though, because I do think one observation is when you speak with most applications,
Mhm.
the goal is let's make life easier for fillers. Let's democratize access to operating a solver. When you speak to most solvers that are operating in the ecosystem and already have their setup, they like if you can make their life easy, but they're often not, their primary motivation is not to make life easy for other participants to come and swim in their pool. They
Yeah.
they actually are interested in more exclusivity,
Mhm.
if that makes sense. And I think this is a really interesting juxtaposition and something that needs to be balanced carefully because it's not unreasonable. A filler often will prefer a just in time, or I'm sorry, a request for quote, an RFQ, because it gives them an exclusive window if they win the quote to go and provide the fill.
Mhm.
And that means that they don't have to amortize and build in the risk that their fill will fail. So, and of course, it means that they don't have to race to go fill it and can work to procure the tokens that are needed for the fill on a more relaxed cadence or source them from their own inventory, bring them over to the chain where they're needed. There's a number of reasons why you would do that. But I do think that um, there are some really serious benefits to the end user if you can run a competitive auction. And one of the key issues with a request for quote is that oftentimes a filler that wins this RFQ doesn't have a they don't have a strong, credible commitment on their end to now that they've said they'll fill it to go and fill it. So what's actually one area where I'm really excited to explore leveraging the compact is on the filler side, where to make a bid, you're actually making a credible commitment that can be executed by some kind of settlement engine, or even just placing a bond,
Yeah.
so that if you don't follow through, then the swapper that you just walked away from their trade when it would have been most profitable for them because it was no longer profitable for you, at least they get they get some recompense.
I think bonding is definitely an interesting design mechanism that you can add at a certain point in like the life cycle of an intent based protocol, like depending on the order flow, right? So I think every intent based protocol has different game theory because of the different type of like order flow that they're able to generate, and based on the order flow you have certain negotiation power with the solvers, right? So not every negotiation is the same, and like deals have to be made in a way where uh, you have to ensure that the solvers get enough order flow for it to make sense for them to actually show up, right? So anyone who's like starting an intent based protocol today, like they would have to have certain exclusive order flow deals, whereas I would assume like something like Uniswap, which has tons of order flow, you can make it super competitive and like actually impose certain reputational like staking or bonding onto the solvers where they have to show up with certain like guarantees that they will, follow through on their promises.
You can also imagine that it greatly simplifies this whole process if you don't have to be bonded in a bespoke, specific protocol to be able to service a given group of users as a filler.
Hmm.
This is where having a generic, flexible, permissionless, reusable facility for resource locks really can shine. Because as a filler, I can just I can keep funds in the compact. I can make credible commitments against any protocol that is powered by the compact to provide resource locks, and I can um, effectively use it as my quoting
Hmm.
mechanism with a pretty consistent interface and reuse a lot of that capital across many different applications at once.
Makes sense. And like finally, how would you like to see the compact be used by different application builders in the ecosystem?
So this is one pretty interesting area where I think we could see some real innovation uh, is inverting the traditional flow so that rather than users being in a resource lock, it's fillers that are using resource locks. Extending on that, I think there are really cool potential applications for both counterparties being inside of a resource lock. You can effectively build a central limit order book where all of the, instead of sending your crypto to an exchange or another blockchain, like uh, you know, some other L2 or L3 or whatever, having to bridge everything over there, you just have tokens in the compact on whatever chain you want them to be on and can um, match compacts against one another. This was part of the original vision for Seaport, the NFT marketplace protocol that we built at OpenSea. And it is, in fact, usable for matching different orders against each other, but it's specific to a single chain. So the compact is, in many aspects, it's an evolution of that premise of being able to match multiple orders against each other, right? So I think that could be really cool to explore. Um, I would love to see more people innovating on uh, adaptive or combinatorial arbiters and exploring the design space of when it makes sense to be explicit about how you're proving and passing information across from one blockchain to another, when you want to aggregate multiple sources of information, when you can fall back to optimistic fulfillment, different mechanisms for batching and netting and aggregating proofs. I think there's so much cool stuff to be explored there. And one of the design decisions that I'm most hype on, because it it's effectively the most extensible component of the compact, and one where we knew that there was going to be a ton of innovation the at the proving level, at the interop level between all of these different chains, with native interop coming online, with
Hmm.
lots of different really innovative groups and protocols and projects that are tackling this very issue. And so that's another area where it's a little more infrastructure than application development. But um, yeah, I just encourage any application developer to consider how how they can really improve the user experience by exploring um, ways to unlock new functionality via credible commitments. What can we do if we know that once I commit to something, the follow through is bulletproof? And how does that change some of the trade offs that we're making today by having to wait or not being sure that something will happen?
Yeah, I mean it's a new school of thought altogether, right? And you can probably apply it to everything in crypto, and in many cases, it'll actually end up improving on the user experience and certain guarantees. Zero Age, it was super insightful. Thanks a lot for your time and all of the thinking behind the compact and how it should be used and how it was built. I hope like it does see the adoption that you've imagined it to see.
We are even we're excited to be using it at Uniswap Labs, and I hope that others join us. I mean, I know that you guys are also going to be joining us, which is really exciting. And ultimately, I think it will bring a lot of cool functionality to the space, and I hope that other projects can see that as well.
Amazing. Thanks a lot for your time today.
You too. Bye.